Good morning, and welcome to JDK 9, 10, and 11, Pitfalls for the Unwary. Now, I like to start these presentations with a little bit of a survey of the audience. So, who here is using JDK 8? Aha, very good. This is the intended audience. Anybody here using JDK 9 in production? Interesting. All right. Anybody using JDK 10 in production? Oh, interesting. A few people. What about 11? Okay, some brave people. Okay. So what I'm going to do here is to hopefully tell you absolutely everything that you need to be aware of when you move an application from JDK 8 to 9, 10, or 11. And let's face it, you're not going to move to 9 or 10 if you're not already using them. Because if you're thinking about moving to 9 or 10, don't. Because they're feature releases. They're not long-term support releases. So they've already stopped getting updates. So if you're thinking about moving to the newer version of Java, then what you want to be focusing on right now is JDK 11. So let's talk about JDK 9. Now, I borrowed this slide from Oracle. I used to work for Oracle, so I figured that they owe me the fact that I can use some of their slides occasionally. And what this does is it lists out all the changes that made it into JDK 9. And I think on this slide there's about 86 changes. Many of them are very small. Many of them are at a very low level. They're changes in terms of how the JVM works internally. But some of them are bigger. Some of them are things that you will see in terms of your applications. Clearly, we need to think about compatibility. And the thing about compatibility with Java is that we have always in the past been used to the idea that compatibility is very important. The idea that you could take an application that was compiled on, let's say, JDK 1.1, and you can run it on JDK 5, you can run it on JDK 8, and then theoretically you should be able to run it on JDK 11. So Sun and then Oracle have always been very concerned about compatibility. Yes, there were a few things along the way that kind of caught us out. So if you look at JDK 1.4, there was the introduction of assertions. So assert became a reserved word in Java. That meant you couldn't call your variable name assert anymore. JDK 5 had enumerations. So enum became a reserved word, and you couldn't call your variable enum anymore. Now, I'm sure that nobody here would use enum as a variable name. I said that when I was talking about JDK 5 back many, many years ago, and I said, of course, nobody would use that. And then I compiled some of my own code, and I found that I had used enum as a variable name. But the reality there is that the changes were not significant. If you needed to modify your code to work on JDK 5, it was a simple pattern match, search and replace type of thing. Deprecation was introduced way back in JDK 1.1. This is the idea that as we evolve an API, it's not just about adding things. There are going to be frequent times when a newer version of something comes out that's better, and so what we need to do is we need to say, okay, let's remove that older version because the newer version's better. Similarly, there might be things that are no longer required because they're such old technology that people just aren't using them anymore. So we've got deprecation. And the reality with deprecation is that as of JDK 8, I counted them up, and there are 492 deprecated elements. So that's methods, classes, interfaces, and so on. In JDK 8, none had ever been removed. So we've been deprecating things all the way through the history of Java, but never actually removing any of them. Until now. Obviously, with JDK 9, that changes. Now, what the developers of Java have said is that deprecation is a good thing. Deprecation is going to be more used in the future, but they will give you a warning about things being deprecated before they're removed. And they will give you at least one release warning. Well, that's great, because if they gave us less than one, that would be no warning at all. So I'm glad they did that. But we are getting some warning about features being removed. And JDK 9 really started this long overdue idea of cleaning up the Java platform. as I say, we've been through this idea of adding more and more features to Java, making it more powerful, making it easier to develop code, but we've never actually removed anything from the JDK. And it's kind of got to the point after 23 years, or 24 years, I guess, that we need to do some tidying up. We need to have a bit of housekeeping, cleaning up, and removing certain things. So in JDK 9, they said, yes, we will finally remove certain APIs that have been deprecated, and this is just the start. In the future, we'll also continue this process. Now, if you ask Oracle, they will tell you things like this. This is Mark Reinhold. I think he used this in his keynote this week, but this is from another keynote he gave. And he said, if your code only uses standard Java SE APIs, then it will most likely work without change. Now, I don't know about you, but I'm a little less than reassured when it says most likely. I'd like to say, well, definitely, rather than most likely. But there are reasons for this, which is what we're going to explore in the rest of the presentation. Similarly, this is another quote from Oracle's product management. They say, clean applications that just depend on Java SE should just work. Again, a little element of doubt there. Right, so in JDK 9, the really big change is the module system. So let's talk about what that means in terms of migrating applications from JDK 8 without modules to JDK 9 where you have the module system. So the reality of modules and the Java platform module system is there's two sort of major things to this. The first is that the core libraries of Java are now broken up into a set of modules. This was the idea that, again, over time, we've added more and more features to Java. Back in JDK 1.0, there were 211 public classes that you could use to develop code. In JDK 8, there's something like 4,500, which is great because now we don't have to write our own semaphore class, we don't have to write our own SQL connection class, we don't have to write our own array list class, all of these types of things. So that's really good. But by adding them all to a single monolithic rt.jar, or actually there's two, because there's rt.jar and tools.jar, having just two jar files with all these things in has got really a bit unmanageable. So the primary thing with the module system is breaking up these 4,500 classes into distinct modules which give us a cleaner design, a cleaner way of separating out different pieces of functionality. If you look at the open JDK, then there are 75 modules in that. 27 of those are Java SE. Actually, there's really 25, but there's two that are counted as Java SE. There's some weird ones because there's Java card is in there, but it's a little bit odd. But anyway, there's 27 Java SE modules, and then there's 48 which are JDK specific. And that's the whole set of things around tools and other bits and pieces. If you look at the Oracle JDK, before JDK 11, there are 14 additional JDK modules. They've got JavaFX in there, and there are a couple of Oracle-specific ones. So from a development point of view, this is not too much of a problem for us. All they've done is separate up into modules, and then what we can do is with things like JLink, we can build a runtime that's tailored to our specific application. So compatibility-wise, not really a problem. Then there's the other part of modularity, which is encapsulation. And this is a big thing that the designers of the module system wanted to do. If you look at the rt.jar file, there's these 4,500 public classes, but there's also a number of private classes which are put there to make the public ones work. Now, the most famous or infamous of these is sun.misc.Unsafe. And I like this class. The reason I like it is because the clue is in the name. Unsafe. Don't use it. So let's have, again, a little show of hands. Who here has used sun.misc.Unsafe in their code? A few people. OK. Who here has used a third-party library or framework like Spring, Log4j, something like that? Yes, you've used sun.misc.Unsafe, you just don't know it. The problem was that they wanted to encapsulate these APIs. That means making them invisible, so you couldn't access them anymore. It would lead to a cleaner design. It would lead to the elimination of certain problems, especially around the possibility of security vulnerabilities. But they discovered that lots of people had used sun.misc.Unsafe and other APIs in their code or their frameworks or their libraries. And it wasn't going to be a realistic proposition to do that because of compatibility issues. So there are command line options, which we'll talk about in a moment, which allow you to turn back on access to these things. So how do we migrate our applications to the module system? Well, the first thing you can do is simply ignore the module system, which is really nice because you can say, okay, the module system is there, we've divided up the JDK into modules, and I don't care about that. So I'm going to leave everything on the class path, and that will still, in theory, work. What you get then is everything that's on the class path becomes part of the unnamed module. So there's one big unnamed module, and the way that works is it has a dependency on all the other modules which are on the module path, and you can have the module or the classes there working quite happily with the modules that you need from the JDK. So initially you can just leave everything on the class path, and everything, aside from the other things I'm going to tell you about, should just work. What you can then do is you can gradually migrate to the idea of using modules. So you can take your jar file and, again, make no changes to it at all, but rather than putting it on the class path, you put it on the module path. So it becomes what's called an automatic module. An automatic module is one that doesn't contain the module info.class file, so it doesn't have the module information, but it can be treated as a module. And from the point of view of the module system, what that means is that the name of the module will be the same as the name of the jar file. The packages that you have in there all will be made publicly available to other modules on the module path, and there will be a dependency between that module and everything else that's on the module path. So it basically just says, right, treat it like a module. Because we don't know specifically which things we depend on, we'll depend on everything. And that makes it easy to do that. What you can then do is obviously move to the idea of full modules, where you create the module info.java file, you can specify explicit dependencies, you can specify which packages you want to make publicly available from your module, and then you can compile that and run it on the module path, and everything will work quite happily. So there's sort of 3 stages to the idea of using this. So the diagram here just kind of reiterates that. What we can have is the class path, where the jar files we have on the class path, everything there is part of the unnamed module. The dependencies between that are such that if we have some jar files on the module path, we automatically have a dependency on those. So we don't need to specify explicitly, and the necessary classes will be resolved against that. What we can then do is move jars, as I said, to the module path without including a module info.class file, so that they become automatic modules. And again, the dependencies are resolved quite happily. You don't have to do any extra work. And then the last phase is simply adding the module info.class file so that that jar file becomes a full module. So as I say, 3 different ways of doing that. Now, if we need to reverse encapsulation, as I said, there are some command line flags that you can use to simplify your life if you want to use some of these internal APIs. There's what's called the big kill switch, which is a great name for a command line flag. And the flag itself is illegal access, which is, it sounds scary, but it's not. And what that has is 4 parameters that you can pass to it. So you can say that by default, the level that is set, if you just run without actually setting this explicitly, what you'll get is permit. And what that means is that when you run your code, you will be able to access internal APIs, but the first time you access an internal API that really should be encapsulated, you will see a warning message, but only the first time. If you're looking for more information, you can set this to warn, which will give you a warning every time that you access an internal API. That way you can see just how frequently you use a particular internal API. Then if you want even more information, you can set it to debug, and that will give you a warning each time you use an internal API, but it will also give you a stack trace so that you can find out where you came from in terms of your code, so you can go back and think, can I replace this with some public API? And then the last one is to deny, which is to turn off access to the internal APIs. The idea that the JDK developers have said is that at some point in the future, we don't know when, the default will become deny. I suspect it's going to be quite a long time before they do that, but we don't know. If you don't want to just do the sort of blanket idea of turning on access for all APIs, then you can do it in a more refined way. So you can say, okay, I want to add exports, which means that if your class is importing a particular package or a particular class and makes use of it directly, then you can do it with this flag. So you can specify, in this case, we've got add exports, the Java management module, and then we want a package within that, which is com sun JMX remote internal, but we're only going to expose that to the mytest package. So the idea here is you can restrict access to specific packages for specific modules. If you want to grant blanket access to that particular package, then you can do something like this, where you say the Java management module and the sun management package is available to all unnamed. So it makes it available to everybody on the class path. The other way of accessing APIs that people use a lot in this type of environment is through reflection. So there's a separate command line option, add opens, which will allow you to make those APIs available for reflective access. So again, you can say add opens, java.base module, java.util, and make that accessible to all the classes on the class path. So if they want to use reflective access to that, then they can. If you want to avoid having to use the command line flags, you can actually include information in the jar file manifest. So again, same sort of pattern of usage. We can say add exports, java.base, sun.security.provider, and that will grant the encapsulated API access to everything that's in that jar file. So it's, again, so where if you want to provide jar file as a library and you don't want your users to have to add things to their command line, then you can encode it directly into the manifest file. Finding dependencies. So yes, okay, so if we're using code, wouldn't it be nice if we could figure out what things we're using without having to run the application and try and run it with all possible combinations of input? So there's a command called jdeps. And what you can do with that is you can specify where your modules are coming from, you can say what modules you're interested in, and then you can say, give me a list of all the dependencies that I have on the different modules and also internal APIs. So what I did here was I have an application that I've written. It's a sort of basic data entry type application that has a screen with some fields and you enter data and that sort of thing. But it used JavaFX, and so I found this was quite a useful thing to do as a test. I wrote a blog entry on this because it was about using JLink. In fact, I also found an error, or found a bug in the jdeps command where I managed to get it to emit a null pointer exception, which was a little less than desirable, but fortunately that got picked up, and I think they've already created a fix for that. So what you do is you say, okay, give me the jdeps, and then what you'll see is something like this. So you see it needs java.base. Well, everything's going to need java.base. Then it needs java.data transfer. I must admit I'm a little bit confused about some of the way that it outputs things. So really what I just wanted was the modules that I wanted. But in the case of desktop, it actually also tells me certain things about some of the, I guess, their internal APIs that I'm using. Then we've got logging, scripting, SQL, XML, and JS object. Unsupported, yes. So unsupported is in there, which is the place where you'll find sun.misc.Unsafe. And so that gives you a list of all the modules you need. So if you wanted to create a runtime for your application, you could take the output of this, feed it into JLink, and create a runtime that would work with your application. Missing modules. Right, so in JDK 9, if you remember, one of the quotes from Oracle was that clean applications only use Java SE. Now, they're very explicit and very clear about what they mean by this. So Java.SE is what's called an aggregator module. And if you look at the JDK, there are two aggregator modules, Java.SE and Java.SE.EE. It's a little bit confusing, but there you go. And so if you only use the things from Java.SE, everything should just work. But if you use Java.SE.EE, then you're going to have some issues. So in JDK 9 and JDK 10, the java.se.ee aggregator module and the modules that it references are still in the JDK. But when you compile code against that JDK, or if you run code using that JDK, that aggregator module and the modules it references will not be included by default. So that's both at compile time and runtime. What does that actually mean? Well, it means that these are the modules that you will no longer have access to. That means if you've written code which uses functionality from these modules, then when you try to compile it in JDK9, it won't compile because it won't be able to resolve things. And if you try and run a compiled application from JDK8 on JDK9, and it uses any of the things in these modules, it won't run. So the things that are affected are Corba. Anybody here using Corba? Nobody. Well, okay, that's good. So we don't have to worry about that one. So Corba and transactions are part of the same thing. Java activation is the Beans activation framework. One person using Corba. Okay. Oh, activation, okay. XML bind, which is JAX-B, so that's okay, a few people using that. But the big one is anybody using web services that are SOAP-based. Yes, quite a few people put their hands up. And I find that when I talk to audiences, that this is something that will affect compatibility, because the JAX-WS, the Java API for XML web services, that's the thing that's no longer included. And that actually is something where if you look at some of the Apache libraries sit on top of this. So you might think, well, I'm using the Apache library, not the one in the core JDK. You're still going to be caught out by this. So that could be something that will affect a number of people. So if you want to use those in JDK9 and JDK10, then there's a couple of different ways you can. They're still there, so you can still make use of them. But what you need to do is turn on the access to them. Simplest way to do that is to say add modules and then the name of the module that you want. So if you are using Corba, then just add modules java.corba. All of these modules, with the exception of Corba, have standalone versions available. There is a JSR for each of these. There's a reference implementation that's available. And if you go to Maven Central, there are modules or packages that you can download from Maven Central. So from that point of view, it's reasonably easy to fix this problem, and you can get those there. You can do it in a number of different ways. Okay, deploy the standalone version on the upgrade module path, so you can actually add it to the module path, or you can just deploy them again on the class path as a jar file, and again, everything will get resolved. So there are different ways around that, but you can resolve the problem on JDK9 and JDK10 without too much difficulty. Small incompatibilities in JDK9, things that might catch you out. Right, first of those is a change to the language specification. So a single underscore is now a keyword in Java, which seems a little odd. Anybody here use a single underscore as a variable name? Ooh, one person, okay. Well, you can't anymore, because if you try and use a single underscore as a variable name, it will say it's a keyword and may not be used as an identifier. Don't worry, you can use 2 or more underscores as a variable name. I checked it, it does work. Now, the logic behind this is that in, I think, maybe JDK 12 may even be later than that, there is the idea of extending the use of a single underscore in Lambda expressions. So you can use a single underscore as a parameter to a Lambda expression where that parameter is not used in the body of the Lambda expression. So it's sort of a way of hiding how the parameter is used. Is that the way that you use a single underscore?
That is precisely the way that I currently use it and will not be able to until they bring it back.
Right, yes. So at least you're using it the right way. You're not using it as like, you know, like int underscore equals 3, and then try and manipulate it. Anyway, right, yeah, so 2 or more underscores can still be used. Right. As I said, they finally have decided to delete some deprecated methods and actually classes and other elements. So in JDK 9, they went all out and decided to remove 6 whole methods. Out of the 458 that have been deprecated, 6 of them got removed. So if you look, there's java.util.jar, pack200, unpack200, and logging.logmanager. All 3 of those have 2 methods, add property change listener and remove property change listener, that have been removed. If you use those methods, your code will no longer compile, your code will no longer run. Now, obviously, you have to look at that and think to yourself, well, what did those 6 methods do that was so bad that they got removed? And the answer is actually quite straightforward. It's when they started to try and divide up the rt.jar into all these modules, they found there were some very odd links between different parts of the system. And by removing these 6 methods, it actually simplified a lot how they could divide things up in terms of the module system. There are still some weird links. So if you use something like JAX-WS, well, you still can, that has a dependency on the Bean framework, which has a dependency on the desktop module. So using web services actually has a dependency on the desktop module, where you think, how is that possible? And the reason is that the Bean framework has a Bean descriptor, and clearly the intern that they gave this job to decided to add an icon to that, which needs Java 2D to render it, so the Bean framework needs desktop, so there you go. Like I say, some weird connections. They deleted a whole class in JDK 9. Now, this is not part of the Java SE standard. It's part of the Java Application Authentication System. It was deprecated way back in JDK 7. So if, bizarrely, you are using com.sun.security.auth.callback.dialog callback handler, then you will no longer have access to that class. Anybody here using that? Anybody know if they're using that class? Probably not. I haven't found anybody yet who's using that. Now, the other thing that they've included is another tool which helps you with understanding if you have used deprecated elements. JDepreScan, introduced in JDK 9, statically analyzes your class files, your jar files, and looks at the standard Java SE APIs and says, are any of the things you're using deprecated? And then gives you a little report. So I wrote a little sample application which used a whole bunch of deprecated things, and this is the type of output you get. So it says, okay, in this case, we're using the RMI security manager, which is deprecated. We're using get selected values from JList, various other things. But it tells you like a report of the things you're using, so you can go back and look at your code and think, right, can I replace this with non-deprecated methods and clean up my code? Structure of the JDK and the JRE has changed. Now, the reason I'm telling you this is because if you rely on certain files being in certain places for the JDK, then this may affect the compatibility of your application. There's probably not many people that do that. Maybe if you're doing something like an IDE or some sort of tool, then you will, but I'm just telling you this for completeness. So in the old days, before JDK 9, we had the idea of a JDK directory, which had a bin directory, which had a copy of the Java executable in it. Then we had a JRE subdirectory, which had a bin directory, which had a copy of the Java runtime in it. So you got 2 copies for the price of 1. Now, this was good because it separated out the idea of the Java runtime from the Java development kit. That meant that you could say, okay, if I only want to install the Java runtime, I need less space rather than installing the compiler and the Java H and things like that. So that has changed. In JDK 9, we now have a flat directory structure. So what you'll find is you've got a bin directory which has got Java in it, it's got Java C in it. You've got a conf directory which is new. That allows you to see the files that you might want to change in terms of configuring your JDK. It used to be they were spread around in many different places. Now they've all been put in one place. It's things like sound configuration. It's things like font configuration, stuff like that. Things that most people don't change that often, but you know where they are now. Lib directory for native code, and the jmods directory, which is where all your modules are. So the tools.jar, rt.jar have gone away. No separate JRE directory. The whole idea now is to use JLink to build a specific runtime for your application. Version string. Right, so I did some research on this, and it turns out that in Java, we've had almost as many version strings as we've had versions. Literally every time they change it. And if you look at the history of Java, we started off with JDK 1.0. Great, very logical. Then we had JDK 1.1. Already a mistake. Should have been JDK 2 because there were some big changes in terms of inner classes and stuff like that. No, we called it 1.1. Then we had 1.2, then we had 1.3, 1.3.1, 1.4, 1.4.1, 1.4.2. Then we had a change of management, so we had Java SE5. Actually, it was Java 2 SE5. Then we had 5.0. Yeah, it had a .0 on the end. Then we had Java 2 SE6. No, or did we drop the 2 then? No, we dropped the 2 then because there was never going to be a Java 3. Then we had Java 7, Java SE7, Java SE8, so it was all looking good. But the problem is that if you do a Java minus version, what you'll actually see with JDK 6 is 1.6, or 1.7, or 1.8, so it's not quite right. So if you download Java SE8 update 1.131, and you do Java minus version, you get 1.8.0_131. Bit hard to parse, bit hard to understand. Also, we get complicated situations where if you look at JDK 7 update 55 and update 60, which one's actually got more patches? Logically, you'd think 60. No, it's actually 55. No idea why. So now we have the new, super improved version string system. Now, hopefully, this is the end of it. Hopefully, there will be no more of this messing about with version numbers. So it's a 4-number system separated by periods. So we start off with feature, that's the main number, great, so that's 9, 10, 11, 12, wonderful. Then we have interim, which is always 0. Okay, well if it's always 0, why do we need it? But apparently that's reserved for future use. At least we're putting in some future-proofness there. Okay, then we have update, which is clearly, well, clearly. So JDK 9, right, that came out. First update to JDK 9, 9.0.1. Wonderful, that's very logical. What do you think the second update to JDK 9 was? Well, you'd think it was 9.0.2, but you'd be wrong. It was 9.0.4. There is a reason for that, because they wanted to save some space between in case they had to do an emergency update. They moved away from that, so now it's 10.0.1, 10.0.2, and logically so on. If there's an emergency update, they use the patch number at the end. So there's a nice, easy way of understanding the version string format. Again, the reason I tell you about this is because if you're using the version string and looking at it in your code, then you may have to make some changes. Things that are non-programmatic issues that might affect your application. So the Java Network Launch Protocol is part of Java Web Start. And the configuration files for that are basically XML-type files. In the past, they were parsed in a way that was, would allow you to get away with certain things which weren't strictly correct. So there were certain places where you could do that. Now they're parsing them strictly, so you might find that some JNLP files that you've created won't parse on JDK 9 that would parse on JDK 8. The extension mechanism, the endorsed standards override mechanism, these have both been removed because they were no longer required with the implementation of the module system. But what that does mean is that things like Java Home lib ext and Java Home lib endorsed are no longer used. And in fact, I know I've used the ext library with JNI in the past and put some libraries in there. You can't do that anymore. If you create an ext directory in the Java Home lib and you try and run your code, this will happen. You'll actually get a message that says the extension mechanism is no longer supported, use -classpath instead. Could not create the Java virtual machine, so won't let your Java virtual machine start. So it's an important one to bear in mind there. Lots of GC options got removed in JDK 9. These had all been deprecated in JDK 8. So there's various combinations of things that they didn't want to support anymore, things like incremental concurrent mark sweep, some concurrent mark sweep stuff in the foreground, the idea of using the parallel new collector with the serial old collector, which I really don't understand why anybody would do that anyway. But all of these combinations have gone away. So if you've been using them in the past, they won't work, but if you've been using them in the past, you will have been getting warning messages anyway. Logging. So logging got changed in JDK 9. The way that the JVM does logging, so it's not the logging API, it's the way that the JVM does logging. What that did was it switched to using a universal logging system common across all the components of the JVM. Rather than them each having their own way of doing logging, now it's just one system. And of course, GC logging is going to use that. And this is one of the things that's important because a lot of people do create GC log files, they want to analyze those, they've written code that will parse the log files and generate graphs and things like that. So these are things where you might have to look at the output and see whether it's changed and whether you need to change your code. Lots of flags have disappeared in JDK 9. And so I'm not going to go through this whole list, but essentially there's a whole range of flags which are basically ignored now, and what you'll see is an error message, or a warning message, I should say, which says, okay, this 60-port server, ignoring options such and such, support was removed in JDK 9. So that's all right, you see, because we can basically ignore that. It doesn't stop our JVM from starting, so we just go, okay, well, we'll go back and change our startup script at some point, but we don't need to worry about it right now. There are a number of flags that have been replaced. These are sort of quite important because many of these are ones that are frequently used. Print GC details. These are the type of things that a lot of people do use to generate log files for their application. So there's a set of alternatives that you use now because of the unified logging system. So it's -xlog::gc, -xlog::gc star. Again, I won't go through all of those. The slides will be up on SlideShare after the presentation, so you can download them, you can have a look at those, and you can get the reference to that. I've also written a couple of blogs which contain all this information as well. Deprecated APIs. So there's lots of flags that change, and you'll get two different warning messages. One which will say, print GC is deprecated, it will automatically use the right one instead, so that's good. Then you get one which says, okay, this is deprecated in JDK 9 and may be removed in future. So it's not automatically using an alternative. Non-starters, right? So there are 50 command line flags on JDK 9, which if you've used them in JDK 8 and you just move your application to JDK 9, they will stop your JVM from starting. It'll say unrecognized JVM option, could not create the Java virtual machine, fatal exception. And things like print heap at GC, that will stop your JVM from starting. Things like trace dynamic GC threads and so on. Those will stop your application from starting completely. So those are things to bear in mind. Right, JDK 10. What's changed in JDK 10 that we need to be aware of? Fortunately, less, because there was only 6 months of development. So fortunately, there's less that we need to worry about. Okay, the first of these is local variable type inference. Java now has the ability to use var rather than an explicit type definition when you create a local variable. So that's now a reserved type. This is quite important because var is not a reserved word. If it was a reserved word, you wouldn't be able to use var as a variable name. But var is a reserved type, which means that you can say var equals new array list of type string. I don't recommend that because it wouldn't necessarily be a good readability type of thing, but you can still do it. What you can't do, which you would have been able to do in JDK 9 and earlier, is create a class called var. Now, I know nobody would do that because, of course, var with a lowercase v goes against the convention, but technically, you could have done this in JDK 9 and earlier. You can't do it in JDK 10 and later. So you can't create a class var. You can create a class var with a capital V. That will still work. So you could have var with a capital V. Things that were deprecated that are now removed. So there's the entire jdk.security.auth module. That's gone. The com.sun security auth package. There's several parts of that have disappeared, mostly around things to do with like Solaris. So there's a couple of Solaris things there, policy files, X500 principle. And in the Java com.sun.security.auth.module package, again, a couple of Solaris specific things have been removed. The Java.lang security manager has had some updates. So there's an in-check field that's gone, and a number of methods here, class depth, class loader depth, various things like that. These are things which most people haven't been using, so there shouldn't be a big impact in terms of application portability. Another few deprecated things in terms of the Java.lang runtime. There are a couple of obsolete internationalization methods that have been removed, get localized input stream and get localized output stream. Again, if you've been using those and you migrate to JDK 11 or 10, then you will find an issue in terms of having to recompile your code or change some of the use of those. A couple of minor things. The Java H tool was removed in JDK 10. Now, if you're going to use Java H for JNI type things, then you do Java C -H. So not really a big change. And the policy tool has also been removed. Command line flags, again, lots of command line flags. So the -D32 and -D64 no longer work. And that's really because the whole idea of a 32-bit JVM support went away. So now there isn't the D32 or minus D64, and again, that will cause your JVM to not start. And then there are 5 minus X options that went away. So there's these things here. I did look those up, and I must admit, some of them I couldn't even figure out what they did. So minus X, SQ, no pause, no idea what it does. Bound threads, I do know what it does, but not SQ, no pause. Right, JDK 11, the most recent one. Right, so the important thing here is that we need to look at what we mean by the JDK. Because Oracle, in terms of JDK, well, starting JDK 10 really, but JDK 11 most importantly, are producing 2 different JDK binaries. The traditional one, the one that we all download from java.oracle.com, has always been available under the Oracle Binary Code License for Java SE. That has changed, so it's now under the Oracle Technology Network License Agreement. And that prevents you from using it in a commercial deployment without a support contract. You can still use it for testing, you can still use it for development, but not in production. To make sure that Java is still free, Oracle also provide an Open JDK. Now, I know that sounds a little bit silly to say the Oracle Open JDK, but this is how Mark Reinhold wants us to refer to it, because he wants Open JDK to be used as an adjective, not a noun. So that's under a GPL v2 with Classpath exception license, so it's completely free in terms of no restrictions in terms of how you use it. What they've done to simplify things is to eliminate functional differences between the Oracle JDK and the Open JDK. What does that mean? Well, if you now are moving to the Open JDK binary, whether it be from Oracle, whether it be from Azul, Adopt Open JDK, or anybody else, there are certain things that you will find are not there anymore. So JavaFX has gone away. That's not such a bad thing in the sense that it's still available as an open source project. You can download the modules, you can download the binaries from Gluon, and you can just put that into your build, and it will work in exactly the same way. The browser plugin has gone away. Anybody still using applets? Oh, okay, one person. Bit of a problem there. Right, so no browser plugin in JDK 11. Also, Java Web Start. Anybody using Java Web Start? Yeah, okay, also a bit of a problem. Yeah, so Java Web Start been around for a long time, and there isn't an easy solution to this. And the reason I say that is because Oracle have not open sourced the Java Web Start code. So there's no ability to just replace it with a simple open source implementation. Other people have tried to create open source implementations in the past, but they've kind of not gone all the way. They're very old, haven't been maintained. There are some other alternatives like Getdown, Install4j, things like that, but they're not simple drop-in replacements for Web Start, so you need to be aware of that. What's the suggested replacement? Unfortunately, there isn't one. The only thing you can do is stay on JDK 8 and pay Oracle for a commercial support contract if you want to continue using it with updates. Tools. Lots of tools have disappeared from JDK 11 in terms of if you compare it with the Oracle JDK before. So the removal of applet support, there's no more applet viewer. The fact that the Corba module is going away, the IDLJ, OrbD, server tool, tname serve has gone away. JMC, the mission control, although that's been open sourced, it's now available as a standalone package that's not shipped with the OpenJDK binary. Java Web Service, as I say, has gone away, so SchemaGen, WSGen, WS Import, XJC, and the deployment tools, both Java Packager and Java Web Start, Java WS, are all removed as well. Few APIs have been removed. The key thing here is that the java.se.ee aggregator module has completely disappeared from JDK 11. Whereas before in JDK 9 and JDK 10, it wasn't used by default, but was still there, it has now been completely removed. A few other things that have gone, so there's various methods here, so there's like the auth policy class, runtime run finalizers on exit has disappeared. A couple of things around the security manager have been removed. Run finalizer on exit again from the system class. Thread.destroy and thread.stop, but only the one which takes a throwable as an argument. There's a no-arg version of this which is still there. So thread.stop, but only with throwable. A few miscellaneous things that have disappeared. SNMP monitoring support has gone, so the JDK.SNMP module has been removed, and subsequently this thing called JVM management MIB has been removed as well. A couple of things around the desktop, so the T2K font rasterizer has been removed, and the JDK no longer comes with any fonts. So all font usage is done directly from the operating system. There's no standard fonts shipped there. A few security certificates in terms of the root certificates have been removed from the trust store. These are essentially old ones that are no longer relevant, so they've done a bit of tidying up there. So there's miscellaneous things. Command line flags, we'll come back to those again. We do like command line flags. Big changes. If you look at the differences, JDK 9 removed 187 -XX options. The fact that it removed 187 tells you that there must be an awful lot of these things if we can remove 187 and not really notice. JDK 10 removed 36, JDK 11 has removed another 27. There's a really great website. If you go to Chris Who Code's hotspot option differences, he's got this little tool which generates these reports of all the options which have been removed, all the options that have been added, and there's links to different bits of information about those. So that's a really good thing if you're interested in more detail about the command line flags and how they change, then that information is available there. So to conclude, since I only have a couple of minutes left, migrating to JDK 9, 10, or 11. Okay, so the idea is simple applications. If you take your Hello World application, it will just run unchanged. If you start going outside of the standard libraries, or even if you stay in the standard libraries and you use some of these things like web services, then you will need to think carefully about how you migrate your application. Leaving everything on the class path is a good way to start, then gradually migrate to automatic modules and then to the idea of full modules. The encapsulation, as I say, can catch people out. In terms of the JVM flags, you need to identify which things you're using, make them available in a controlled way. Smaller changes may catch you out in different ways. And then just lastly, one slide of marketing, is Zulu Java is our build of the OpenJDK. So we pass all the TCK tests, we support JDK 6 all the way through to 11, and we have wide platform support for not just 64-bit, but also 32-bit Windows and Linux, ARM 32, 64-bit, PowerPC. Have a look at it if you're interested. It's free, or we'll do you a very reasonably priced support contract. And with that, thank you very much.